So here we have a basketball set, a portable basketball set, and a base and post arrangement. And we can see that this base can be filled with water to increase the stability so it doesn't topple over easily. The first part of this question asks you to show that the maximum weight of the base is around 870 newtons. So weight and the maximum weight, we straight away go with the expression the weight is equal to mass times gravitational field strength. Because it's talking about the maximum weight, we're expecting that it's completely filled up with water. So it has a capacity of 85 liters. It's been given to you that 1 liter equals 1 kilogram, so that would contribute to 85 kilograms of water can actually fit in that base. But the base also has its own weight, the plastic around it, and which is 3.5 kilograms. So the maximum mass that the base has is 3.5, which is the weight of the container, and 85 kilograms of water inside, and times that by 9.81 and you get 868 newtons, which is approximately 870 newtons. Okay. Part B, here we have the basketball arrangement, and if wind blows in this direction here hitting the backboard, there's a chance that the basketball set may topple over. Okay, so the forces that are acting on this basketball set arrangement are the weight of the base, which is acting vertically downwards here, the weight of the base. You've got the weight of the post arrangement, so this section here, that has a weight acting in this position vertically downwards, and there is another force acting on the backboard, which is the wind pushing it and trying to topple it over. Okay, so in this particular position, you have three forces, and we can clearly identify the pivot point is here. This is our focus. This is where we start off. We identify this entire object is rotating around this point here. Okay. Now, it says calculate the minimum force of the wind that will cause the basketball set to be blown over when it is at the angle shown. Ignore any effect of the wind on the base. So the idea is these are the only three forces in play: 1, 2, and 3. Now we can see that this force creates a clockwise moment. This force creates an anti-clockwise moment around this pivot, and this force here also creates an anti-clockwise moment. So that's the second thing that you must notice. Which directions are these moments? Are they clockwise or anti-clockwise? So we've got two anti-clockwise and one clockwise around that particular pivot. We can clearly see that this distance and this force are not perpendicular to one another. So the force that we are looking for is the weight of the base multiplied by cos 15. We have already shown that the weight of the base is approximately 870 newtons. So that mg is 870 times by cos 15. And the clockwise moment will be that 870 cos 15 multiplied by the perpendicular distance of 0.45. Now we know just before it topples over, sum of the clockwise moments is equal to the sum of the anti-clockwise moments. So let's have a look at the anti-clockwise moments. Now we can also see that this distance from the pivot, 2 meters, and this here are not perpendicular. So I need to find a component which is perpendicular to this distance of 2 meters. Now, the weight of the post arrangement here, this angle is 15 degrees here, the angle of tilt. Okay, so that means that this angle here is also 15. So that angle there is 75. Okay, or you can say this angle here is 15 degrees. Okay, now similarly, we know that this angle here is 15 degrees, so that means if it's tilting to the left by 15 degrees, it must have tilted up by 15 degrees as well. And just like objects on an incline, then that means this angle here is 15 degrees as well. Okay, so if I know that you could use either cos or sine. So here you could have used sine 15 of this angle, which is this component, or cos of 75. So the weight of the post arrangement multiplied by sine 15, or you could have done cos of 75 here. And either way, you would have got the same answer. So we know that the weight of the post arrangement is 27. So this here is 27 newtons, and sine 15 or cos 75 multiplied by the distance to the pivot, and that gives us the anti-clockwise moment due to the weight of the post arrangement. We also have another anti-clockwise moment, and if the post arrangement has been tilted by 15 degrees, then that means that this here, the perpendicular component here, is also a 15-degree tilt, because this is horizontal, and we can see that that component will be the force of the wind multiplied by cos 15. That will give us the perpendicular component to the distance to the pivot, which is 2 meters plus 0.4, which is 2.4 meters. So that there is the force, Fw cos 15, which we're trying to find out, and the perpendicular distance here. Okay, so we must be always looking for force and distances which are 90 degrees to each other. So that's why for all three forces, we have had to find the perpendicular component of that particular force. Applying that to the principle of conservation of moments, clockwise, anti-clockwise moments are equal. We see that if we rearrange for Fw, that the force of wind required, the minimum force required, is 157 newtons. Okay, so that's this is rearranged for Fw, which just gives us that there. Part C. Now, the base is filled with sand instead of water. We know that sand has a bigger density, therefore greater mass, so therefore greater weight. The density of sand is greater, therefore they've just given you that. State and justify what would happen to the value of Fw calculated in part B. Okay, so what we look at is if the sand has a higher density than water, then we know it's going to have a higher mass. Okay, that means that it's going to have a greater weight. Now, if we look at this, that means that this moment is going to be larger. And as we've done in our calculation, that clockwise moment is countered by some anti-clockwise moments. So that means that the anti-clockwise moment due to the force of wind must be larger to counter the clockwise moment. Okay, and hence the force of the wind must be also larger. So my answer says that the force of the wind increases because there is a greater clockwise moment as the base is heavier. To counter this, the anti-clockwise moment must also increase. Therefore, the force of the wind increases to ensure this.